everyone, this is Mrs. Pettit, and I am also one of the math teachers here at Darien High School. Today I'm going to be walking you through adding and subtracting rational expressions. If you remember from when you learned how to add rational numbers, the first thing you need to do is find a common denominator. So in example number 1, the least common denominator would be 10. If I want to write the fraction on the left with a denominator of 10, I need to multiply the denominator by 2. But if I'm going to multiply the denominator by 2, I need to also multiply the numerator by 2 so that I don't change the problem. I've essentially multiplied the left-hand fraction by 1. So when I multiply that left-hand fraction, both the numerator and the denominator, by 2, I end up with 4 over 10, and the right-hand fraction I can leave as 3 over 10. If you remember when you learned how to add rational numbers, you only add the numerators. You keep the denominator. So when I add the numerators of 4 plus 3, I get 7 over 10, and that's our answer. Let's walk through another example of adding rational numbers. The least common denominator between 7 and 3 would be 21, which means the left-hand fraction, I would multiply both the numerator and the denominator by 3, and the right-hand fraction, I would multiply both the numerator and the denominator by 7. When I multiply through, that gives me 9 over 21 for the left-hand fraction and 14 over 21 for the right-hand fraction. When I add the numerators but keep the denominator, I end up with 23 over 21. Now that we've had a little review of adding rational numbers, let's see if we can extend that to adding rational expressions. My plan is to walk you through the 6 steps in example number 3 at the same time. The first thing we want to do is factor each denominator. The fraction on the left has a GCF of x in the denominator, so I'll factor that to x times x plus 1. And the fraction on the right is all ready to go. The second step is to determine the LCD, or the least common denominator. In our case, the least common denominator is going to be x times x plus 1. The next step is to multiply both the numerator and the denominator of each fraction by the factors that are missing from the least common denominator. I'm going to simplify that a little bit to multiply by the missing factors. So in the left-hand fraction, we're not going to have to do anything. In the right-hand fraction, we'll need to multiply both the numerator and the denominator by x. The next step is to simplify the numerators. Again, we don't have anything to do on the left-hand side and really not much to do on the right-hand side, but I'll just simplify it to make it look a little bit cleaner. Step number 5 is to add the numerators. And when I add 3 plus x, I end up with x plus 3 over our least common denominator of x times x plus 1. The final step is to state our restrictions, just like we've been doing all along. So we want to state the restrictions. So for this particular problem, x cannot equal 0 and x cannot equal -1. I'm going to add a couple steps to step number 6, because if we can factor the numerator, we'll want to do that. So I'm going to say factor the numerator if possible, and simplify. In this particular case, we are not able to simplify any further, so this is our answer. If you want to follow along and have another example, let's take a look at example number 4. If you want to try and give it a shot on your own, pause the video and try it on your own and come back and see how you did. Again, the first step is to factor each denominator. So on the left-hand fraction, I can use sum product factoring, and I get x plus 1 and x plus 4. In the right-hand fraction, I have 5x and a GCF of 3 that leaves me with x plus 1. The next step is to determine our least common denominator. So in this case, our least common denominator will be 3, x plus 1, x plus 4. So we need to multiply both the numerator and the denominator of each fraction by the factors that are missing from the LCD. So in the left-hand fraction, I'll need to multiply the numerator by 3, keeping all the pieces of the least common denominator, and the right-hand fraction by x plus 4 in both the numerator and the denominator. Our next step is to simplify the numerators. So in the left-hand fraction, that simplifies to 3 over 3 times x plus 1 times x plus 4. And in the right-hand fraction, simplifies to 5x squared plus 20x over 3 times x plus 1 times x plus 4. Step number 5 is to add the numerators. So I'll get 5x squared plus 20x plus 3 over our least common denominator of 3 times x plus 1 times x plus 4. And now we want to state our restrictions. So in this particular case, x cannot equal -1 or -4. I want to double check to make sure that I can't factor the numerator any farther. And in this case, I cannot. So that is our final answer. So that this video doesn't get too long, I'm going to pause here and pick up with a new video to walk through subtracting rational expressions.